Picture a pack of small but swift predators weaving through the underbrush of late Cretaceous Mongolia. Each is no taller than a large dog, but with razor-sharp sickle claws, keen eyesight, and surprising intelligence. These are velociraptors, not the oversized monsters of Jurassic Park, but real, feathered hunters that rewrote what it meant to be a dinosaur. For decades, Velociraptor has been one of the most misunderstood dinosaurs. Popular culture turned it into a scaly, 6-foot-tall terror from Hollywood. The truth is even stranger. With feathers covering its body, Velociraptor bridged the world of dinosaurs and birds. Those feathers were not just decoration, they were tools that gave this predator deadly advantages. In this episode, we unravel the tactics that made Velociraptor such an effective hunter, explore the role of its feathers, and dive into the science that transformed it from movie monster to scientific icon. The story begins in the blazing Gobi Desert of Mongolia, 1924. An expedition led by the American Museum of Natural History uncovered the first Velociraptor skull. It was smaller than expected, just 25 centimeters long, but with a long, narrow snout and a mouthful of serrated teeth. Henry Fairfield Osborn named it Velociraptor mongoliensis, the swift thief. The name fit. Its skeleton showed adaptations for speed and agility, long legs, lightweight build, and a deadly curved claw on each foot. For decades, paleontologists knew Velociraptor as a small, fleet-footed predator. Yet, it lived in the shadow of larger carnivores like Tarbosaurus. Only in the late 20th century did its true significance emerge, as new fossils revealed connections to birds. That discovery would change everything we thought we knew. The most iconic feature of Velociraptor is its second toe claw, a sickle-shaped talon that could grow more than 6 centimeters long. Unlike the claws of other theropods, this one was held off the ground, kept sharp for battle. Scientists once imagined velociraptors slashing their prey open with these claws, gutting animals with a single leap. But modern research suggests something subtler. The claws may have been used to pin prey, much like modern eagles use their talons. With powerful legs, velociraptors could leap, hook their claws into struggling victims, and hold them down while delivering repeated bites. This technique would have been devastating in coordinated pack hunts. Small but efficient, velociraptors could overwhelm prey much larger than themselves. Their claws were not just weapons, they were tools of control, precision, and deadly teamwork. For decades, dinosaurs were imagined as scaly reptiles. Then came a wave of discoveries in the 90s from Liaoning, China perfectly preserved fossils showing feathers on small theropods related to Velociraptor. Soon after, direct evidence appeared on Velociraptor itself, quill knobs on the forearm bones, exactly like those in modern birds, where feathers anchor. This was the smoking gun. Velociraptor was feathered. But what were the feathers for? They were too small for flight. Instead, they likely provided insulation, keeping Velociraptor warm in Mongolia's desert climate, where nights grew cold. Feathers also may have played a role in display, allowing individuals to signal dominance or attract mates. Brightly colored plumes, much like those of peacocks or birds of paradise today, could have been a factor in courtship. Yet there's another idea feathers aided hunting. By spreading its feathered arms, Velociraptor could balance during agile maneuvers, stabilize while leaping, or even help pin prey. Modern raptors, like eagles and hawks, do something similar, using their wings to stabilize when grappling prey on the ground. Some even fan their wings to confuse prey, or shade the ground while striking. The parallels between Velociraptor and living birds of prey suggest that feathers were more than just decorative. They were functional weapons of balance, speed, and control. This connection between dinosaurs and modern raptors is one of the most striking revelations in paleontology. It transforms Velociraptor from a reptilian monster into something far more dynamic, a deadly bird-like predator, honed by evolution for precision killing. Few topics spark as much debate as Velociraptor's hunting style. Movies portray them as highly coordinated pack hunters, like wolves. But does the fossil record support that? Some evidence suggests social behavior. Fossils of multiple dromaeosaurs found together hint at group living. Modern birds of prey sometimes hunt cooperatively, so it is not impossible. Paleontologist Philip Currie proposed that dromaeosaurs may have used group strategies to target large prey. But others caution that velociraptors may not have been true pack hunters. Mark Norrell and others argue that fossil associations could reflect individuals drawn to a carcass, not organized teamwork. In this view, velociraptors were more like Komodo dragons, opportunists willing to gather where food was plentiful, but not planning coordinated attacks. The debate has even been compared to modern analogies, wolves versus jackals. Wolves show structured pack hierarchies and planned hunts, while jackals often scavenge together, each individual competing for scraps. Velociraptor may have been closer to the latter social at times, but not truly cooperative. Still, there's a case for middle ground. Studies of tooth marks on Protoceratops fossils show repeated attacks by multiple velociraptors, suggesting some form of group effort. Perhaps they lacked strict teamwork, but shared opportunities when facing larger or more dangerous prey. This ongoing debate reflects how Velociraptor sits at the crossroads of reptile and bird behavior. Its true hunting tactics remain partly hidden in the sands of time. One of the most dramatic fossils ever discovered is known as the Fighting Dinosaurs. In 1971, paleontologists in Mongolia found a velociraptor locked in combat with a Protoceratops. The velociraptor's sickle claw was embedded in the herbivore's neck, while the Protoceratops bit down on the raptor's arm. Both died together, frozen in mid-battle by a collapsing sand dune. This fossil provides direct evidence of Velociraptor's hunting tactics. It attacked live, struggling prey, using its claws to pin victims while slashing and biting. It also shows the risks velociraptors targeted dangerous opponents, and sometimes both predator and prey perished. The Fighting Dinosaurs fossil remains one of the most vivid windows into prehistoric behavior, a split second preserved for 75 million years. It demonstrates not only Velociraptor's aggressive tactics, but also the brutal, unforgiving nature of its environment. Velociraptor was not just fast and armed, it was smart. Its brain-to-body ratio was higher than many other dinosaurs, suggesting advanced problem-solving abilities. Enlarged olfactory bulbs meant a keen sense of smell, while forward-faced eyes gave it binocular vision for judging distances during attacks. Fossil endocast molds of its brain cavity show that Velociraptor had a relatively large cerebrum, the part of the brain involved in decision-making. This suggests it could adapt its tactics during hunts, much like modern birds of prey adjust strategies when attacking agile prey. Its sensory abilities also rivaled those of birds like owls and hawks. Binocular vision meant it could track prey movements with depth perception, crucial for a leaping predator. Its sense of balance, aided by an inner ear adapted for quick movements, let it twist and turn in midair with precision. The comparison to modern corvids, crows, and ravens is particularly striking. These birds show problem-solving intelligence, tool use, and social behavior. Velociraptor may not have been quite as brainy, but it was far from a mindless reptile. Its mental toolkit was advanced enough to make it a dangerous, adaptable predator. Combined with agility, these traits made Velociraptor a precision hunter. Its long tail, stiffened by bony rods, acted like a counterbalance, allowing rapid turns at high speed. Imagine a feathered predator darting through brush, leaping with claws extended, eyes locked on its target. This combination of intelligence, senses, and agility explains why Velociraptor became a symbol of deadly cunning in popular imagination. Unlike brute force predators like T-Rex, it represented speed, coordination, and tactical strikes. When Jurassic Park debuted in 1993, Velociraptors became household names. But there was a catch. Spielberg's raptors were oversized, standing nearly 2 meters tall, closer to the real dinosaur Deinonychus. The name Velociraptor was used because it sounded more menacing. For many viewers, that movie version became reality. Sleek, scaly, and terrifying. Jurassic Park's raptors overshadowed the truth. Only later did science reveal the feathered reality, leaving some fans disappointed. But for paleontologists, this shift was exciting. The real Velociraptor connected dinosaurs directly to birds, showing evolution in action. Feathers made it stranger, not weaker, and while smaller than the Hollywood version, it was no less deadly. Today, documentaries and newer films attempt to restore its true image. Yet the pop culture debate continues. Should velociraptors be shown as science says, or as the monsters audiences grew up fearing? Velociraptor thrived 75 million years ago in what is now the Gobi Desert. Back then, the region was a harsh mix of sand dunes and seasonal rivers. It shared this world with protoceratops, oviraptor, and massive reptiles like giant lizards and crocodilians. Survival here required adaptability. Velociraptor's feathers helped it regulate temperature between scorching days and freezing nights. Its speed allowed it to chase prey across shifting dunes, and its intelligence meant it could exploit opportunities in a dangerous ecosystem. While small compared to giants like Tarbosaurus, Velociraptor carved out a niche as a cunning, mid-tier predator. It may not have been king of the food chain, but it was one of the most efficient hunters of its age.